All right, so I'm starting the recording. All right. So, if you're not in Commerce, then if you will be here on Thursday, I have a stack of papers that you can pick up. If you will not be here on Thursday, it is fine. I will load them into D2L under the Content tab in week 2 so that you can see where we are, and you can just either look at them yourself or print them, like look at them online or print them, whatever works for you. And you'll be here Thursday. I've got extra printouts, so no worries there. I'm just going to run through the pile of stuff that I have back there for everybody to see. So the first one actually that I want to put up is the postulates formula, or the postulate sheet. Okay. And I know it's really hard to see because it's really tiny, but for instance, the first one is the line postulate. And the postulate says you can construct exactly one line through any 2 points. So the thing is that we have different stuff in geometry. So for instance, we have definitions in geometry. Definitions are things that, for instance, you would put into the glossary. Define a line, define a point, define an isosceles triangle, okay, those kinds of things. So define keywords. For instance, an isosceles, I think I spelled that wrong, I think it's just a C there. Isosceles, oh man, I'm not right today. It still doesn't look right. Isosceles. Ah! It was a C. See? Isosceles. I'll get there, guys. Triangle. 2 legs have the same length, or 2 legs are congruent. Something like that. That could be your definition, okay? So whenever we make a definition like that, it's just this is what this is. There's no room for questioning or trying to figure stuff out. So definition's just out there. And then we have different things. So for instance, one of the things we might have is a conjecture. I used that word the other day in class, right? So a conjecture is something that we suppose is true, okay? So it's like a hypothesis. Okay, it's we suppose it's true. Some people might say it needs to be proven that this is true. We don't know for a fact that this is true, but we just we see a pattern and we suppose it's true. So for instance, if I have an isosceles triangle, here's my definition here. I'll draw a little picture there, two congruent legs. Then I might suppose, or I might say, we conjecture that the base angles are congruent. Do y'all know what base angles are? A, B, C. Then the base angles would be what? B and C, right? So the conjecture is the base angles of an isosceles triangle are congruent. Now, then we can prove that. We can prove that conjecture, that it is true. And so once it is proven, then we can call it like a postulate, which a postulate is something that we just take as a given, okay? So I'll do that one in a minute. But so sometimes you'll see something like this conjecture, and sometimes it'll be a conjecture, sometimes it'll be a postulate. It really depends on whether it's been proven yet or not, okay? So at this point, this is just a conjecture, but we know that it's true that these 2 base angles are going to be congruent. And so we can prove it, and we will, okay? Then once we have it proven, then we can say, oh, it's a postulate, okay? And that's the page that I just gave you guys. So postulates are statements that are assumed to be true. Okay, so a really good example is the one that I read out loud to you. So it says the line postulate, you can construct exactly one line through any 2 points. We just assume that's true, right? We know we can make the distance between those 2 points. We can figure out the slope between those 2 lines, those 2 points. So we figure we can make a line out of it, right? Okay, so it's just something we assume to be true. And the last one is a theory. Okay, and this is a statement that's suspected to be true, but it needs proven. Needs a proof. So until it's proven, it's just a theory. Okay, and some of those are really close to one another, like a postulate and a conjecture. Those are pretty close, right? So what you'll see in the textbooks is sometimes they'll use conjecture and we'll be like, but we know that that's true. And so you might have called it a postulate, and that's fine. Okay, so just be aware. There's just a slight tiny difference. For us, and maybe we've already proven that to be true, or maybe we just assume it. So for instance here, I'm looking at my postulates list again. The third one down, well, the second one says line intersection postulate. The intersection of 2 distinct lines is exactly 1 point. We know that. The only time it's not exactly 1 point is when we had 2 lines and they were on top of each other, right? And then they wouldn't be distinct. So yeah, okay, that makes sense. Segment duplication postulate, you can construct a segment congruent to another segment. You can copy that segment is basically what they're saying. Yeah, we can do it. We may not know how to construct it just yet with our compass, but we'll figure that out this semester. So yeah, we assume if you gave me a length that I can copy that length and duplicate it. Okay, so some of these things we just kind of, that's true, that's true, that's true. So I want you to have this list so that you can kind of refer back to it in the next week or 2. We're going to start working on proofs. Oh, it's going to be fun. Okay. And whenever you see that stuff, maybe you're like, oh, I need to be able to add two angles together. Maybe I need my angle addition postulate. Okay, that's the very bottom one. If that point D lies on the interior of ABC, then ABD plus DBC is the measure of the entire thing. So you can use those things as you need them. There's also stuff on the back. This includes some of the triangle congruencies, which we're going to start talking about today. How do you know if 2 triangles are congruent to one another? There's different things that you can use and assume, and there's some that you can't use and assume. Okay, so we'll talk about those and just different ones there. Follow that up with what I call the word bank. Okay, so this word bank is pretty much exactly what you'll see on a test, because I don't believe in crazy surprises. So I don't expect you to pull names out of the thin air. Okay, what was that? What do I use for 2 parallel lines? Okay, here, look, parallel lines right here. Okay, here are the things we talked about in parallel lines, okay, that we've already discussed so far. So there is something about the vertical angle conjecture. Remember, we had that last week. Okay, if 2 angles are opposite each other in the intersection, blah, 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 then they are congruent. Okay, so that's a conjecture. Now, you're not going to have to regurgitate out that thing, but you do have to be able to look at vertical angle conjecture and know, A, what are vertical angles? And B, what would that vertical angle conjecture tell me? Okay, it tells me that those guys are congruent. Right. So just, if you don't know what's going on in class, just seeing vertical angle conjecture is not going to be enough to help you out, right? But if you've been keeping up with the notes, if you're watching the videos, if you're in class, then you would be, oh, okay, oh, vertical angles, that's what that is. That's the one I need, you know? So it just kind of tips off your brain a little bit. Some of the properties, and some of these you probably already know from your math classes, commutative, distributive, transitive, all that. We'll pick those up as we start working through proofs, okay? Some of them are just algebra properties that we're gonna apply to geometry, and they'll work very similarly, okay? And then here, general stuff, the line postulate, that's the one I just read to you off the postulates page. So this gives you a little more in depth of what those postulates are. This is just like a word bank that you would use on a test. So if you're looking at it and you're like, I don't know what that linear pair postulate is, then take some time as we go through and we talk about, oh, those two linear guys, you go, oh, that's what that means, and jot it down on your word bank or make it in your notes or whatever you need to do so that you can remember those things. Triangles, we're gonna start in them, I hope, today. That's the plan, okay? On the back is all kinds of quadrilaterals and circles. That's on test 2, so we'll worry about that later. Okay? We're only worried about test 1 right now. So there's you a couple of forms that you can look things through. Yay. The ones that I really want to work on today. The ones that I really want to look at today are the other 3. So there is a form, and again, I'll load this into D2L so that everybody can see it if you're not here in Commerce, or you can get it on Thursday. This is the semester-long project. And what it is you're going to pick a topic. I'll show you the topics in a second. Pick a topic, decide what you're going to do, and which one you're going to do. So let me just go ahead and show it. So basically, there's all kinds of stuff that has to do with geometry that I just don't have time to cover in class, right? There's 16 weeks, and we don't have enough time. So it pays off for students to do some projects and play with stuff and then share their experiences with the rest of the group. So for instance, maybe somebody's interested in dice and games that they could use with a class, or activities that they could do outside of school that might be interesting that have to do with dice. And maybe there's some geometry that goes with that, okay, which there's lots of geometry that goes with dice. You could pick that topic, and then you're going to go find 2 activities that work with it, okay, that use dice. And then you're going to write this up. There's all kinds of stuff there about what you're writing up. I'll let y'all read through all that. Basically, it's a critical review of those 2 activities, whether you think they're doing a good job of getting kids engaged and that kind of thing. And I'll give you more details on that later. Don't worry about that yet. That won't be until Thanksgiving. First, pick a topic. Second, find activities. And then you'll write it up. And then that's what we're going to make presentations about at the end of the class right around Thanksgiving. Okay, lots of fun. It's like a week before Thanksgiving, I think. Okay, so, and then the third thing that I gave out, this is the rubric, how I grade based on your group presentations. Normally these are group presentations, like 2 or 3 people in a group. We can do several different things. One is you could work in a group if you have a friend that you feel comfortable with, but I can give you individualized projects if you don't want to work with a group because of the current situation. I understand. And then if we run out of time, instead of making a presentation in the class, you could make a video and post it into D2L if we are short on time. I'd rather people actually talk and communicate, but if we run out of time, we can do that. So that'll be coming up. I know that's a lot to think about. It can get kind of stressful. Yes, ma'am.
Do we still have to have a book activity, or can they go to the internet?
I don't want them both to be internet. So you might look in the library. There's a curriculum library on the 2nd floor.
I think they have one.
You have to request your book through the NLA system, and a student worker will go and get it for you. They'll check it out to you, and then they'll leave it for you on that little shelf thing.
Oh, so annoying. Okay, so let me go over there and play with it and see how terrible it is. I did not know they have things blocked off.
All the stacks are closed, and then there's caution tape around the books on the 2nd floor.
Caution tape. Oh, good to know. Did you grab one of everything back there?
Yes.
Okay, good. All right, so I'll play with it and see. I wasn't anticipating that issue. But I do have some activity books in my office that you could probably check out if you wanted to. Especially like on the normal manipulatives. By normal, I mean like tangrams and pattern blocks and things like that. I have books for those for sure. Dice I probably have. I don't probably have anything on string art or toothpick bridges because those are kind of abnormal. They're not real manipulatives. They're just weird things. So we're talking about the semester long project. So I'm making that assignment. Can more than one person have the same topic? Yes, Jessica, you may. So I will take at least 2 people, up to 2 people per topic. So it's a first come, first served. So if you want a topic, let me know now. She's like looking, going, what do I want? What do I want? So I keep a list and I'll just put your name out beside it, whatever you have. And yeah, we'll do 2. There are 18 topics. There are 18 students. So you could all have an individual topic and I've also had people before that said, can I do, like one guy wanted to do Klein bottle caps. Okay, which is not one of my things here, but he just had an interest in Klein bottle caps and it ties in. And I was like, sure, you can do that. So we worked that out and I just added a topic. So if there's something else unusual that you want to do that's not on the list, let me know.
Mandalas?
Mandelbrot sets?
I think it's the circle art where
So circle art, like, are they using those geo tools? Oh, okay. Yeah, look, talk to me at the end, but yeah, I'm okay with that. Yeah, so if there's something you're like, oh, I know I have, now make sure that whatever it is, that you would have access to some kind of an activity to do in a classroom with students or whatever for that. So, but yeah, absolutely. Woohoo. That it for questions on the chapter? All right, sounds good.
Is there a due date on the topic?
I was actually thinking that people should get me their topics by next week. So that gives you a little bit of extra time to think about it, maybe do some exploring, see if you can find stuff on it, on that, whatever it is. I will tell you, toothpick bridges are really cool. I actually even have an example of one in my office from a previous semester that a student did, but it's hard to find top activities on them. So they're really cool. They're interesting, but you would have to really research for some activities. Okay. Excellent. All right. So that's your thing. So let's say next Thursday on that. Topic for semester-long project. Thursday, what is that? September the 11th? 10th. Thank you. All right. So let me know by then. You can send me an email or you can come by my office or you can just tell me in class, whichever. It's fine. All right. Also, because I keep on forgetting to mention it, some of you probably already know, there's a syllabus quiz online. D2L. So please go take that. I have it due next week, so you've got time on it. I meant for it to be due this week, but I'm forgetting to mention it in class. So go on to D2L, go under activities and quizzes. And it'll be available. It's an open syllabus quiz, so take your syllabus with you. Take a look at it, answer the questions accordingly. Yeah, so I just want you to be a little familiar with D2L, be able to get into activities, be able to get into quizzes, because that's where all the quizzes for our course will be this semester is in D2L. So you need to be able to get there and make sure you understand how those things work and all of that good stuff. So that one, if it doesn't have a due date yet, it will be also Thursday. Give it 1 week. There we go. Do it over Labor Day. All right, so that's kind of my housekeeping stuff. Is everybody good? Ready to actually do some content? All right. Move on. There we go. We saw our heroes. That's you guys. You're the hero of the story. We were on parallel line conjectures, right? And we had done some basic middle school proving so that everybody knew what the different things were, corresponding angles, alternating interior angles, all of that. So if you haven't done that yet, go back and look through your notes, make sure you're aware of what all those things are. And you're okay. The one thing we didn't do, we actually did one and then I didn't call out the word. So let's use this word and make sure everybody knows what it means. A converse. What's a converse? So normally whenever we have a conjecture, we'll say something like, if A, then B. Okay, so for instance, maybe we say, let me stick with the one I've been bugging you about this morning already. If an isosceles triangle, if a, man, I cannot think and write at the same time today. If a triangle is isosceles, then its base angles are congruent. Okay, this is our conjecture. That's been up earlier, right? So if a triangle is isosceles, then its base angles are congruent. And normally that's kind of the way we do things. And so we will start out with the isosceles part and we will work through and prove that the base angles are congruent. And we'll do that as we go through. But then there's this thing called the converse, okay? And what it is we start with the back side of things and we prove the front, okay, if that makes sense. So basically we'll flip it around. So we'll get if B, then A. Okay, so it's kind of like reading the statement backwards. This actually leads me to being able to say if and only if statements, if you've done that before in your classes. So if it works forward and it works backwards, then it works both directions. It's an if and only if statement. So the backwards of this, the converse would be, if a triangle has congruent base angles, then what? Then it's isosceles. Good. And once we have it like that, then we'll be able to say, oh, any property that we have that applies to isosceles triangles, I know I can apply it here, okay, because I have those congruent base angles. So that's the beauty of being able to work forward and backwards. So last week we were doing, let me find it real quick. We were doing those parallel line conjectures. And we had, for instance, the alternate interior angles conjecture, the alternate exterior angles conjecture. And we were right at the point where I was about to say, okay, if two lines are cut by a transversal to form pairs of congruent corresponding angles, congruent alternate interior angles, and congruent exterior angles, then we know the lines are parallel. So it's just that thinking backwards kind of thing. So normally we wouldn't do that. Normally we would say we have two lines, they're parallel, they're cut by a transversal, and therefore they have alternate interior angles, blah, 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 blah. But instead we're going to start with the then part of it. Okay, we know this is true, we know this is true, we know this is true, so they must be parallel. Okay, so it's kind of that converse thing. So that's where we were at the end of our parallel line stuff, and we were almost done. That was the very, very end of stuff. Dang it. So we are at a point where we should be able, oh man, here's my plan of that. We should be able to Did not get it. To do some homework, if I can find my homework printout, it might be in that pile stuff up there. Nobody got a checklist, did they? Files back here. If not, it's probably in my office. It's hiding. No, thought you were gonna get out of homework, but I haven't. So in your book, you should be able to now do page 124. Numbers 1 through 10 all. And page 131, number 1 through 7 all, plus 9, 10, and 14. Okay. So that's your first book work for you to be doing. The semester will be kind of a mixture of little handouts that I give you like I did last week, little things out of the book, and then stuff that you have to do online through the GeoGebra program, which we'll talk about probably next week, so you can see that. Okay, so this guy, remember that I'm giving it on a Tuesday, so it's going to be due in 1 week, so next Tuesday. So it'll be due September 8th. Yay, you can do homework now.
What if we haven't received our book yet?
Say it again, I'm sorry.
I said, what if we haven't received our textbook yet?
Okay, so shoot me a private email if you don't have the textbook yet, and I'll take you a screenshot of my book and send it to you.
Okay.
Like just the exercise set. So I can do that for a couple of homeworks if you're still waiting on a book. I don't mind. Can't do it forever, but yes. So, and then there was a question here that was,
Never mind.
okay, it's the exercise sets, yeah. Okay. Awesome. All right. Let's get going. We're probably ready to do some math. Of course we're ready for math. We haven't done that yet. We need it. Okay, so what we're going to do is talk about triangles. Yay. Moving on to parallel lines. So everybody hopefully knows that a triangle is a three-sided object, closed, right? It's not some open weirdness. What else do you know about triangles?
Some of the angles, the interior angle equals 180.
That's a great conjecture. Sum of the interior angle of a triangle is 180 degrees. I love that conjecture. It's a beautiful one. Do you all know it? Have you all proved it? You've proven it before? Okay. Have you ever proven it with patty paper? Maybe not. Okay. Let's do it with patty paper. It's going to be great. So actually in this class, this is one of the ones we will do both ways. So we'll prove it with patty paper like we would for a kid now. And then later in a week or so, we'll start doing regular proofs like you would write for this. So we'll see it both ways. All right, so this guy, what I want us to do is, I don't want us all to draw the same triangle. Why not? And I want to convince you, or I want to convince a room full of kids, 30 middle schoolers, that it works on any triangle, right? Okay, it doesn't matter. It doesn't have to be a right triangle. It doesn't have to be isosceles, whatever. So I'm going to try to draw mine kind of as a big scaling triangle so that hopefully none of my three sides are the same. But you guys can draw any triangle you want. Just don't try to draw my triangle. And when you do it, make sure that you use a ruler, because otherwise it's very difficult for us to, let's see, let me do like this. It's very difficult for us to make sure that everything lines up exactly. So I'm making mine with one really big obtuse angle. You could make all three of your angles be acute. I'm going to call him triangle A, B, C. And I'm putting my letters on the inside. And the reason I'm doing that in this case is because I'm about to do some tearing up on my paper. And I want the letter to stay with the angle that it's part of. You draw your triangle any size you want. If you are not in commerce and you're never going to come to class, or at least not in the near future, then please send me an email with a physical address, and I can put those packets together for you so you can get some patty paper. Or if you're on campus and you can either come by or get somebody to come by, then I can leave a packet outside my door, my office door, for you to get picked up if you like. People coming to class are getting things that maybe some of you aren't, so I want you to have the resources. Okay, everybody have a triangle? A, B, C. So Summer, right? Summer J. Summer has said that all of the interior angles will add up to 180 degrees. So what I'm going to do is I'm going to rip off my interior angles. So it doesn't really matter how long you made your sides, your legs of your triangle, because you can rip off the entire thing or you can just rip the angle. For instance, I don't need this stuff up here, so I'm just going to take it off. All I want is the interior angles, right? So literally pull off the angles. This is really easy to convince kids on this because, especially if one draws a right triangle and one draws obtuse. Now, what we're going to do is this. We're going to lay out our angles in such a way that they're going to share a vertex. All right, the vertex is going to be the same for all of them. Remember, vertex is the turning point of the angle, or the pointy spot. Okay, and then I'm going to make sure that once I've got their vertices lined up, that the leg that they're sharing lines up as well. So in other words, I don't want this side here for A and this side here for B to not line up because I'm trying to sum them all together, right? She said the sum of all of those angles. So I want to add them all together. So I'm going to make sure that they share a vertex and they share a side. Okay. So I've got my A and my B. And then once I've got that, I'm going to do the same thing with C, and I'm going to make sure its vertex lines up here with the other two. And the side here, I'm going to rotate it until it lines up with that side for B. And now look at that. Again, the beauty of the patty paper is we can see through multiple layers at once. Look at that right there. That forms what? It's a straight line, right? Okay, so it is 180 degrees. We know a straight line is 180 degrees. There's a postulate for that. But once I add up my angles, I see, oh yeah, they do. And if you had three acute angles, if it was like a 60, 60, 60 triangle, equilateral, they would be perfectly split up into thirds, okay? So it doesn't matter, acute, right, all of those, they still fit. That's kind of cool, right? Okay, so Summer gave me that conjecture, you know that? Now we've middle school proven it at least. We'll get around to a more formal brief later. Okay, so we know that about triangles. Awesome, what else we know? You don't know anything?
Many types of triangles.
There's different types of triangles. What types do you know?
Right triangle.
Okay. A right triangle has. Okay, has one angle that is 90 degrees. Everybody agree? What is this statement out of all the things I talked about earlier? Right triangle has one angle that is 90 degrees. It's a definition, right? Okay, so there's no ifs, ands, or buts about this one, right? We're not trying to prove it. We're just, this is a fact, basically, is the way it's been stated. So right triangle, okay, what else you got? You already did isosceles that has two congruent sides, right? What other kinds can I have? Okay, equilateral. Let's get an actual definition for equilateral triangle. Has
60 degrees.
That's not part of the definition. We'll get that one. So hold that for just a second because we're going to give you your own thing. Okay, so the definition for the equilateral triangle is that it has three congruent sides. But what I'm hearing from you guys is that we know if it has congruent sides, it also has congruent angles, right? So that's a conjecture that goes along with it. If a triangle, I'm going to start using my geometry notation here. I'm sorry. I'm getting a oh, I see some answers. Give me just a second, guys. I'm getting a little lazy. If a triangle is equilateral, I'm sorry, we're doing the conjecture. If a triangle, trying to do the converse in my head. No, I was right. Is equilateral in my head, I'm trying to reverse it. Then it has three angles that measure 60 degrees each. Okay. So that's a conjecture that comes along with it. And we know it so much that we just almost think it's part of the definition, right? It's just, it comes with it. Three equal sides, three equal angles. Okay, so we know it, but the definition is about the sides and the conjecture pulls in the angles, and we know that. So in my comments over here, I'm seeing right, obtuse, acute, and scalene. Okay, so I've already got right. Let me get an example of a couple of these in here. Here's one. Here's one. And I'm going to use that one actually for two things. Okay, so this one right here, this first picture that I have here, talk to me about its angles.
Three acute angles.
Okay. Three acute angles. And by acute, remember we mean what? Less than 90 degrees. So this could be your equilateral, right? It could be a 60, 60, 60, and then they're equilateral and they're all acute and we're done, okay? But it doesn't have to be. I deliberately drew it kind of wobbly there so that it would be more pulled this direction. As long as they're all less than 90, you're good, okay? This guy though, what about this angle right here? Okay. An obtuse angle. Remember that means greater than 90 degrees. Okay. Okay, so sometimes whenever we're talking about things like a right triangle, an acute triangle, an obtuse triangle, we're talking about the angles. And sometimes we're talking about the two congruent sides, the three congruent sides, or the no congruent sides, that's the other one. Then we're talking about the sides, but it's a different way to still talk about a triangle. So this one is obtuse, an obtuse triangle, because it has an obtuse angle. but it's also what? Scaling. I hope it's scaling. I didn't mark it, so we'll assume it's scaling because all three sides have different measures. All right. So good. Work on that. Okay, I think I got all the comments there. Thank you guys for chiming in, helping me out. All right, so as you work your way through your book, there's some stuff that they start working on almost immediately. This is even in the beginning of chapter 4. And this one is called, for instance, the third angle conjecture. At some point, we gotta quit making new conjectures for every little thing and calling it whatever. But this one's called the third angle conjecture. And I'm gonna show you what it means or what it looks like. And then you can tell me what the conjecture is. So say I have a triangle. I'm just gonna make it a 90-degree triangle. Triangle right here. And I have another triangle. And I'm going to call this guy D, E, F. And I'm going to call this guy G, H, and I. I should have labeled those triangles up there. Y'all let me get by with not doing that, so sorry about that. I should have labeled them, but they're gone now. So they won't offend us anymore. All right, so there's my picture. What do you think? Talk to me about what you're seeing, maybe.
Two triangles have two angles in common, and the third angles are going to be the same as well.
Okay, so what she's saying is, hey, look. But I heard some were saying, she didn't say it, but I heard it. She said E and H have the same measurement, right? They're both right angles, okay? D and G have the same measurement. She knows that because I put the one little hash mark there inside of it, right? So she's saying, okay, those have the same measurement. So what she's telling me here is that you have two different triangles that have two congruent angles. I did hear her say that. You have two different triangles with two congruent angles. So that tells her what? Yeah, the other angle must be congruent. So Mary said all the equal degrees of the angle, and that, yes. So F must be congruent to H, or I'm sorry, I. So I'll put another little congruency mark there, and we'll mark that out. So this kind of leads us into the next section that we're headed for. All equal degrees of angles, similar triangles. Yes. Okay. So hang on to that thought. So what we've got going on here is I know that these triangles have the same measurement. All of the angles are congruent. We have that in there. The problem is I don't know if they're all congruent triangles, if they're both congruent triangles. So I can figure out the third angle for sure. And that's why it's called the third angle conjecture. See what they're doing to you there? Okay. Whenever we start talking about triangle congruencies or non-congruencies, one of the things that comes up a lot is this one right here. And what we call it is angle, angle, angle. Okay, so what that means is you have two triangles. And all three angles are congruent. Okay, that's exactly what we're seeing here. The question is, so that's what angle, angle, angle means. The question is, are the triangles congruent? Are the triangles congruent? What do y'all think? Got one vote from Mary. Mary chimed in. Do you think they're congruent triangles? Don't yell out an answer yet. Here's what I would like for everybody to do. I would like for everybody, whether you're in commerce or not, to draw yourself a 60-degree, 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 so an equilateral triangle. And we have lovely protractors now, so we can do that. I think that the easiest way to draw a triangle using angles is to start off the base of the triangle and then measure your angles up off of the base. I think that helps. So what I mean by that is here's my base, and from there I'm going to measure a 60-degree angle. Measure. Should have measured is what I should have done. Dang it. How much is my base? I'm gonna make mine 2.5 inches, but y'all shouldn't make yours the same. Okay, here we go. Doesn't really matter because you can make them meet at wherever you want to meet. Close enough. Lengths don't have to be the same. They do if it's 60, 60, 60. My side lengths all have to be the same. I'm going to do the same exact process, creating myself a 60, 60, 60. But I'm using a 1-inch base now. So I have 2 different examples right here. You can include your example as well. We could compare. You could put yours up there and see. Probably, unless I told you, you must create this with a side length of blah, 2 inches, 3 inches, whatever, then probably everybody created a different triangle. And my question becomes, but wait a minute, I have 2 different triangles right here. They're both 60, 60, 60, right? Are those congruent? No, okay. So I think what Mary was saying was what I see in her comment here. Let me call this guy JKL, and I'm going to call this guy MNO. What her comment is for instance, the length of the sides here on JK, that length, does not have to be the same length as MN, even though those are in the same position on that triangle, right? They're both on the left above the base, that kind of thing. So these are in the same position, but they're not the same measurements, okay, lengthwise. The angles are all the same, okay? And same thing for you guys. If everybody drew a 60, 60, 60, then all 3 here sides are the same, but they're not the same as anybody else's triangle necessarily, okay? So these are not congruent triangles. The side lengths do not have to be the same because there's nothing pinning one leg in position saying you must be this long. If I had that, if you said, oh, you must be 2 inches long, then we would, because they're 60, 60, 60, we would force the other 2 legs. But we don't have that. We're only doing angle, angle, angle. So what about that? Mary already gave me a vote. I can't read probably what she wrote. They're not congruent, so the answer is no. They're proportionate. And in geometry, we normally call that similar. Okay. Which means same shape, but a different size. Good job, Mary. Okay. Same shape, different size. Okay. Whereas congruent would mean same shape, same size. Okay. I also see a comment here, you could have done a 45, 45, 90. Same difference, right? If everybody had drawn a 90-degree 45, 45 isosceles guy, then we would all have the same angles, but not necessarily the same leg measures. Okay. So unfortunately for us, even though it's really great, we know these 2 angles, we know these 2 angles, we can come up with the third congruent angle. Yay. It has to be, right? Because if this adds up to 180 and this adds up to 180, if this was, say, 130, then this guy's got to be whatever, 50 degrees, right? Okay, so they have to be, but the triangles aren't congruent necessarily, okay? So what we're going to spend probably the next couple of class periods working on is called triangle congruencies. Okay, so when do we know if 2 triangles are congruent to each other, or if they're only similar, or maybe we don't know even that much about them? That's what we want to know. And what we just figured out is angle, 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 and I'm going to abbreviate that, AAA, angle, 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 is not a triangle congruency. So just be aware of that one. That one's the one that seems to trip most people up, is the angle, angle, angle. You see it, it looks so good because they're all congruent to each other, but the links aren't set in stone, so we can't use it, unfortunately. So that's the big one that's not a triangle congruency. But what about one that is a triangle congruency? Do y'all know one? Y'all know one? There's a comment. Oh, there's a comment. Ah, side angle side. So good. We got side angle side. What does that mean? It's hard. I'm sorry. Mary's trying to communicate with me. So whenever we see a triangle, and I'm gonna start over. A, B, C. Okay. I'm up to O, so I'm gonna start over. So say I have a triangle. Let's just make it a right angle. That makes life easier on us. And then I'm going to draw this other triangle weird. So we'll call him A, come straight down to B, come over to C. I've got that angle. Okay, I'm going to draw the other triangle kind of upside down. I know it makes life harder whenever I do things like that, but hopefully I'm not too far off. And we'll call this guy D, E, and F, and we'll make E be also a 90-degree angle. Okay. So there's some ways that we always talk about these congruencies, so I just want you to know. For instance, when I said angle, 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 I would normally start in what we call corresponding positions, okay? Just like on the corresponding parallel lines. So which two, if I said angle A here, which angle in the other triangle corresponds with A? D. because it's the one that is on top of the 90-degree angle, right? It's up above it, it's the vertical, so on and so forth. So A and D are in the same position. B is, of course, in the same position as E, because those are both your 90s, okay? And then C is in the same position as F. We can think it's kind of the pointy acute angle that's out here by itself. When I read these off, if ABC is congruent to the other triangle, then I need to read them in the same order that I just said, okay? So if I call this guy ABC, then this guy is DEF. Now I labeled those so that they would be in order, but like the other day we had that triangle pro or whatever, PRO, so it's not necessarily in order. You have to make sure of those things. Okay, so we're gonna do that. Now, she said side angle side, so let's look at that and see what side angle side looks like. Angle side, that is definitely one of them. Okay, and you'll notice they've got all these little abbreviations. That's SAS, side angle side. Okay, well, I know that the angle for B is the same as angle for E, so let's just build off of that. As I go around, I'm going to go in the same order as the other stuff, and I'm going to do it the ones that are touching each other, if that makes sense. So I'm going to put a mark here for AB and 2 marks here on BC. What side corresponds with AB on the other triangle?
DE.
DE. So it should have 1 mark. And for BC, I should mark
FE.
FE congruently, right? Okay. So whenever we read this guy, we say, look, here's a side, AB. It's actually connected to the angle for B. And then that's actually connected to the side BC. Okay. So that's why I'm saying like they go in order. They're all connected. You wouldn't talk about the side AB, the angle C, way off here by itself, and then the side AC. Okay. So they're going to be in order, they're going to be connected, so be careful of that. Okay, so when I say that, I can say, okay, this side is congruent to this side, that's in order. This angle is congruent to that angle, and this angle is congruent, or this side's congruent to this side. Okay, so what Mary's saying is side angle side is indeed a congruency. Okay, everybody just going to take her word for it? Yes, we want to take her word for it. No, we can't. All right, so we're gonna grab a patty paper. Or you don't even have to do this on patty paper, actually. Well, patty paper is probably easier. But you can do it on your paper probably instead of patty paper if you don't have one. So it'll be all right. So here we go. I'm going to give you 3 measurements, and I want you to create them. And then we will talk about if they are congruent or not. So we're going to create triangle DEF. And what I want, let me write that here. Triangle DEF. And what I want is for you to do side DE. We're going to call that one 2.5 inches. We're going to make side DF, and that's going to be 3 inches. And then we're going to measure an angle D 50 degrees. Okay. So let's think about this for a second. We got to create this guy from scratch. She's just giving me a couple of measurements here. If it's too big for your paper, you could probably do centimeters instead of inches. That would be fine. How am I going to create this triangle? I just have 3 little pieces of information. Where do I start? Do I start by making the 50-degree angle out of nowhere? Probably not, right? I probably need to start with a leg. Does everybody agree with that? If I can, then I can create one of the base or one of the legs, okay? So do we care which one I use for the base? Nobody cares? Okay, so I'm gonna do DF because it's the longer one. Okay, and I'm gonna make that into my base. I'm just gonna make it a straight line. You can do either 3 inches or 3 centimeters. Inches or centimeters is better for your paper. Straight line that's 3. Mine's gonna be inches because I want y'all to see it. Inches long. All right. And that was DF. Now, how do I create angle D, which was 50 degrees, using this as my base? Well, how do you measure an angle? What compass? You use a protractor, right? Use a protractor to measure. So I'm just going to tell you there's 2 different things. There's a protractor, it's for measuring, and the compass is for constructing, okay, for creating circles and stuff like that. So arches, whatever. So whenever I want to measure this guy, I want him to measure 50 degrees, right? I need to use a protractor. Hopefully that makes sense. Okay, so here I go. Here's the 50 guy. So there's the point that I want to connect from the D, but I want this side to be what? 2.5 inches long, because that's my side DE, right? Okay, so I need to make this 2.5 inches. Now it's got to go through that point, but for my purposes, I need it to be longer, right? Because I need 2.5. So there's 2.5. DE. Okay, so it seems a little complicated. You're like, dang, I never knew drawing an angle could be so complicated, right? But you just, it's like, where do I start? I don't know where to start. Start with a leg almost always, and then build your angle off of it, and then build the other leg. Does that make sense? Okay, so now I still don't have a triangle. I only have an angle, but what? Just connect the dots, right? Okay, I know that the third side has to be EF. So we'll just connect the dots, and you can just use your ruler to do that. We don't have to measure because it just is whatever measurement it is, right? What is that? Let's see. It's looks like 2.7-ish. Sorry, 7/16. 2 7/16. So it's not even a nice pretty number. Okay. There we go. We got 3, we got 2.5. This guy was 50 degrees. Okay. We all did the same process, right? Basically. Yours might be a little bit different than mine because you did, there's human differences, right? Human error, whatever. But what would you say if I asked you to place my triangle on top of yours? You don't have to. But what do you think? Just kind of look at them, make sure that our 50 degrees lines up, right? Look about the same. Yeah, you can just kind of lay them on top of each other. And because we're using pattern paper, maybe. Oh, that's okay. You did centimeters instead of inches. You did like centimeters instead of inches also, right? Okay. So if you did centimeters, it's not going to be the same as mine because I used inches. But other than that, they should be about the same. So what that tells us is, there we go. They look the same, right? I'm using the middle school proof with you guys. You did centimeters. Okay. I'm using the middle school way of proving things. See, they're all the same, so they must be, right? Okay. So what we're saying here is we have the same side followed by the same angle followed by the same side. So therefore, and ours are all congruent. So therefore, we think they must be congruent. Okay. And in fact, we are correct. That is one of the things that we can use for a congruency, okay? So the question becomes why? And here's the deal. This angle right here, basically because it's 50 degrees, it locks those two sides in place. Does that make sense? So they're stuck. They can't, they're a certain length, they have to be because we were given that, and they're locked in place because they're attached to that 50-degree angle. So because of that, whenever, it was Maria, right? Whenever Maria said, you just connect the dots, right? Connect the E to the F. We were forced for that third measurement. Does that make sense? Like, because these are stuck, the third measurement is forced into whatever it is, and it just is. You know, we can't change that. We can't go, oh, I only want it to be 2 inches, because then it won't meet. You know, it won't be a triangle if we do that. So that's what's going on with side angle side, and the key here is this angle is locking pieces in place, okay? All right, so that's one, I agree. What's another one?
Side, side, side.
Side, side, side. I like side, side, side. So hang on a second, because when we had angle, 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 it didn't work. Okay, so the question becomes, do we think that if we have a side, 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 it will work? Okay, but there's 3 of that. There was 3 of the other one. Let me give you an example. Y'all know Pythagorean theorem, right? Okay. There's Pythagorean triples that come in there. What's a famous Pythagorean triple? Oh, I don't know your triples. Oh, that's good for me. That means I can throw stuff at you and you won't know it. Okay, a famous Pythagorean triple is, I don't see anybody saying one, so here we go, 3, 4, 5. Yeah, the 3, 4, 5 Pythagorean triple, right? You've heard that one before. So what that means for me is the 5 has to be the hypotenuse. What's a hypotenuse? The long side, right? That question?
1, 2, 2 times square root of 2.
Okay, so now you're getting into trig stuff on me, but yeah, I think so. It's like the one for the 60, 30, 60, 90 is like 1, 2 square root of 3. Is that right? Something like that. But yeah, so you, whenever you're doing 45-degree angles, it's the 2 square roots of 2. Yeah. So those, there's, if it's a right triangle, I'm not seeing anybody cheering. Sometimes people will tell me stuff, but if it's a right triangle, then it holds that particular ratio, right? It has to. So the 3 squared is 9, the 4 squared is 16, and when I add those together, I get 25, which is 5 squared, right? Pythagorean theorem. Okay, so if I tell you guys, everybody create a triangle that has these measurements for sides, side lengths. Okay, and again, you can use centimeters or inches. I'm gonna do it on my paper this time. It's a little bit tricky because, can't measure. It becomes a little bit tricky because whenever you go to put side lengths up beside each other, it's like, how do I make it work? It's gonna be way too big. That's okay. It'll work out. There we go. We see that my third side is a 5. Good. All right. It's a little bit tricky because whenever I just have side lengths and I don't know what the angles are, I have to kind of play timber or something like that. Put one side down, make it your base, and then put the other 2 sides, if you have 2 rulers or 2 compasses or something like that, that you can say, okay, I need this 4-inch and I need this 5-inch, and then you can lean them until they make a connecting point, an intersection. Then you can finish creating your triangle. What happens is, even if I kind of cheated because I knew the 3 and the 4 have to be the legs and the 5 has to be the hypotenuse. So I cheated and made that be my right angle. But if not, you can still do it because you can go, okay, I know this guy needs to be 4 inches. This guy needs to be 5 inches. Here's my vertex. Lean them together until they meet. Okay, there's my thing. So when you get there, maybe your right angle is in the bottom left like mine is, but if not, it's okay. It can be like top right. It doesn't matter, because when I pick my paper up and put it on yours, I can rotate, right? And whenever I rotate it around, they'll line up. So everybody should have a 3, 4, 5 whenever they create it, and it should be a right triangle. Even if you didn't measure it at 90 degrees, it's still going to be a right triangle, because that's what it takes for those lengths to meet. Okay. So yeah, those are 2. So I am just about out of time. I got like 2 minutes. There's more triangle congruencies. We'll pick those up next time. I haven't called roll yet, so let me do that real quickly just to make sure I got everybody who's here. Okay. Gabriel, right?
Yes.
My 2 G names. Just straight. Alexis is here. There's some J. Elijah, I didn't see. Angelina here. Mary's here. Ryan's here. And Garrett over here. I got you. Okay. So that's it for today. No new homework. I gave you that stuff, page 124, 131. That'll keep you busy. So make sure you go do that from the parallel lines from the other day. I should have probably given it to you on Thursday, but got it with me. So awesome. If you have questions, stick around. Otherwise, thanks. Have a great day. If you are listening, I'm stopping the recording. Have a great day.